Now, thus far, we've been working blissfully unaware of the fact that Josh in engineering is working on this at the same time that we are over in design. So at the moment, we've been working in our top-level design assembly, and as it turns out, Josh has been working in a top-level engineering assembly, and that is separate from our design document, as you can see here. But what's nice about that is that if we look in the engineering file, Josh is referencing that same Atom 002 file that came from our first iteration phase, and it's right here in our folder. So we see right off the bat, working in external files rather than virtualized internal components makes for a much more flexible workflow because both Josh and I can be working with this same file at the same time. We're not making changes to it, we're just using it as a common reference. So I've been working on the ID master. Let's take a look at what Josh might have been working on over in engineering. So here we are in the engineering file, and this is what we've passed to Josh, and I'm over there in the other room working on the ID master model. And Josh is tasked with seeing, well, how do we make this thing work? What's going to make this thing tick? Well, first of all, Josh is going to go to probably Insert, Component, New Assembly. And he's going to right-click that assembly and save that assembly in an external part and rename it Component Drop 1. Okay, so we're basically creating a sub-assembly in here. And the reason that we're doing that is because when I add these components, there's a really good chance that Adam over in design is going to want to add these same components into his model and be able to build around them. So the same way that Adam is currently building an ID master model, it's kind of like building, you could think of this as the engineering master model, okay? And then we can share those. So let's edit this sub-assembly now. I'm inside that sub-assembly. You can see that it's blue. And I'm going to go back to my folder here, and I have a couple of things already built. It happens that I have a PCB here. I'll just drag that into my assembly. I've also got a battery, a AAA battery. I'm just going to drop that in as well. Let's just open this sub-assembly in a new window. There we go. And let's show the planes for that sub-assembly. Make sure that planes are visible. Here we go. And now we can take that PCB and start locking it down into place. Now we can set an origin constraint, but as we know, that kind of locks us in. I'm actually going to go ahead and do separate mates for each plane. So I'll do my front plane to the front plane of my assembly and hit OK. I'll do my top plane to the top plane of my assembly and hit OK. And the right plane to the right plane of the assembly and hit OK. It's still centered. It's the same as using the origin constraint. It's just that now I can individually control those. If I want to change one of them but not the other two, then that works. All right, so we'll exit that. Also, I'm just going to drag around this battery. We can go to the right view and drag it because we want it to be below our PCB. So I'm just going to drag that down below the PCB. We'll look at this from the top. Zoom in some. I'll drag this over so it's right underneath the PCB. And actually, let's look from the bottom here. And I actually want two of these batteries, and basically they need to be mirrored, right? One of them is flipped over, but it doesn't matter for our purposes right now. This is just volumetric. So in our assembly here, let's go to our linear component patterns. I'll do my mirror components. I'm going to grab the right plane of the assembly as my mirror plane. Not the right plane of a part, but of the assembly. And the components to mirror, we're going to mirror this battery. And go to the next step, and it's going to show us an opportunity there. And actually, we can see different alternatives here. And look at that. Number 4 happens to flip the polarity of this thing. So we'll just do that. Hit OK. So now we've got our two batteries in place. And if I drag one of them, they're going to stay lined up properly. Nice. All right, so those are right where we want them. I can close up this assembly and go back to our main assembly. And there it is inside of our our design. And obviously, the back of this is going to have to get bigger, and that's okay. But this is a good starting point to see what's going to have to fit inside of this product. Okay, so I'm done being Josh for a little bit here. We've done our engineering work for the day, shoddy as it may be. And but now the important thing is the output, right? The important thing is now I'm going to go File, Save All, just so I can save everything I've done, and go back to my folder. and we're going to see that we have my top-level engineering assembly there, but we now also have another assembly file called component drop 1, and that's the one that we just created. It's important that that was an external file because in the next video, we're going to go back to our design file. We're going to import that, and we're going to use it to make some adjustments to our ID master model based on what we've learned about the components from the work Josh has been doing separately over in engineering. All right, let's go.